Okay, and one more final example on how to use normal distributions and z-scores to help you find percentages, all right, of different applications. So here we go. On a website that has a brain games and cognitive test, the distribution of reaction times for a certain clicking task allows for approximately normal distribution of, with a mean, once again, the normal distribution, woo, good thing to know, mean of 284 milliseconds and a standard deviation of 50 milliseconds. What percent of the people take longer than 300 milliseconds to complete the task? All right. What we have right here is, once again, create a normal distribution. Okay, we have 284. We're looking at 300. 300 is going to be over here. Okay, we're talking about takes longer than that. So we're looking at this one. I'm going to label this distribution at 284 and then 50 milliseconds. Okay, and we're looking for this percent. Now, if you watch my previous videos, you understand that we first want to find our z-score because we're going to use table A. So we're going to find my z-score by taking 300. We're going to minus 284. I'm going to divide that by our standard deviation, which is 50. So if you put this in your calculators, all right, and you take 300 minus 284 and then divide it by 50, you get about 0.32. All right. And so what we have right there is we found, if I converted this, all right, into a normal standardized distribution, okay, we realize we have 0, and then we found this one thing is there's a 0.32 standard deviations away from the mean, okay? So now I have to go over here and figure out, okay, what is my percentile? Because what we're going to do is we're going to use our table A to figure out what is this area, because whenever we look at a table A, it's going to give us this percentile area, all right, that we're looking for, okay? And so right here, I'm going to take my table A, all right, and I'm looking for my positive portion, okay? And you can see that I finally found it, okay? And we're going to look for is 0.32, 0.32, and you see that it's going to be located right there. Put the little arrow there, and I'll underline it. Okay, so 0.3 and then 2. So that is my percentile. Okay, all right. And so this is going to be at the percentile if I call this x, x being the number of milliseconds it takes to complete the task. This would give me all the values that are less than or equal to that value. So at 0.32. Okay, actually that would be our z-score. Okay, z. And so the probability of taking would be 0.6255, which then gives me a percentage of 62.55. Okay, now because I transformed this p-value is going to be the same thing as if I had x. Once again, I said it before. All right, everything's going to be less than that. All right, 300. But that is not what I'm looking for. All right, what I'm looking for is actually the values are going to be greater than that. So what we have to do is, in order to answer this true question, what is the probability of x, all right, being greater than or equal to 300? Okay, what we know, okay, is that we can take this value, all right, and because this is a percentile, is positive or less than, all right, you can have this not equal to there, all right, because it doesn't really matter that much because it's just simply a line when we have that. And so if we just take this value of 1 minus 0.6255, all right, that will give us our final determination of what that true value is going to be. And so we find out this percent is going to be all right, 3745, which is, we know, 37.45%. And that is how we answer the problem. And that's what we got. Okay? And so using the z-score, The z-score gives us, all right, the value, and then we look at our table A, gives us our percentiles, because remember these are percentiles. And so going from here, we can figure out a probability statement for everything less than that. But then answer the problem, because how long does it take to get longer than that? Okay, so longer means larger. And so we're looking for values that are greater than or equal to 300. And so it takes longer than 3,000, so I guess it would be equal to, I apologize. All right, but in any case, it's going to equal the same value, and then we have our answer. Okay, well, let's look at the next problem here to see what will this give us. So it says, move this down a little bit. It has been claimed that to be a serious video gamer, all right, a person needs to be in the fastest 1% of all reaction times. What time would a person need to get in his clicking task in order to be considered a serious video gamer? Okay, so what time would they need? So we're looking for a time. So looking for the x value. Okay, the x value being in the fastest 1%. So essentially, once again, we're looking for right here, if we had a normal distribution of 284 and then 50, we're looking for the top 1%. Okay, so we're looking for 0.01, 0.01. All right, what is that top 1%? Okay, now think about this. Where is that as a percentile? Well, that is going to be in the 99th percentile. All right, 99th percentile. And so looking for that value, and when we have a 99th percentile. And so we're going to use our table A to help us figure this out. And once again, taking this out, all right, I'm going to just delete that right there. And looking at that, we're looking for the 99th percentile, okay, and the closest to that 99th percentile, okay. And if you keep on going, 90.99, 0.99, 0.99, 0.99, 0.99, 0.99, and we are getting right about there, okay. And if I take this, okay, and this appears to be the 99th percentile, so 2.33, 2.33, okay. And so what we found is that right here, for a z-score, okay, because that's all we can find are z-scores using table A. We found that the 99th percentile is 2.33, all right, 2.33. So what does that mean? Well, that doesn't help me out what this actual x is in the problem I'm looking for. So this is what we're going to do. We're going to take our z-score of 2.33, and we're going to use that to help us calculate it. X is what we're looking for. We would get that if we took 284, all right, divided by 50. And so now we're going to solve for x. So 2.33, we're going to multiply that by 50, do a little math, plus 284. And what we have is x is going to have to equal, all right, 400.5, 400.5, all right, 400.5. And that's going to be milliseconds. Okay, so 400.5 milliseconds, that will get you into the 99th percentile approximately, all right, which is actually the top 1%, okay, the top 1%. And that's what we know, okay? All right, and so, once again, going through here and identifying these different things, all right, it is key to use a table A when you're doing this, remembering that we want to translate all these things into z-scores, and using z-scores of a normal distribution. You only can do that when you have a normal distribution, so it's important that it says it's normal distribution, and then identifying the mean standard deviation allows you to use the z-score, table A, to get the percentile, and then you can convert that percentile into whatever you want, whatever you want. All right, well, I hope this helps you out, how it presents, and also values. So good luck and God bless in the rest of your problems.